All right. The second assumption is the so-called no endogeneity of regressors. It refers to the prohibition of a link between the independent variables and the errors, mathematically expressed in the following way. Think about it. In this case, the error, thus the difference between the observed values and the predicted values, is correlated with our independent values. This is a problem referred to as omitted variable bias. Omitted variable bias is introduced to the model when you forget to include a relevant variable. As each independent variable explains why, they move together and are somewhat correlated. Similarly, y is also explained by the omitted variable, so they are also correlated. Chances are, the omitted variable is also correlated with at least one independent x. However, you forgot to include it as a regressor. Everything that you don't explain with your model goes into the error. So, actually, the error becomes correlated with everything else. Before you are too confused, I'll give you an example. Imagine we are trying to predict the price of an apartment building in London based on its size. This is a rigid model that will have high explanatory power. However, from our sample, it seems that the smaller the size of the house is, the higher the price. This is extremely counterintuitive. We look for remedies, and it seems that the covariance of the independent variables and the error terms is not zero. We are missing something crucial. Omitted variable bias is hard to fix. Think of all the things you may have missed that led to this poor result. We have only one variable, but when your model is exhaustive with 10 variables or more, you may feel disheartened. Critical thinking time. Where did we draw the sample from? Can we get a better sample? Why is bigger real estate cheaper? All right, let me give you more information. The sample comprises apartment buildings in central London and is large. So the problem is not with the sample. What is it about smaller size that is making it so expensive? Where are the small houses? There is rarely construction of new apartment buildings in central London. And then you realize the city of London was in the sample. The place where most buildings are skyscrapers with some of the most valuable real estate in the world. We omitted the exact location as a variable. In almost any other city, this would not be a factor. But in our particular example, the million-dollar suites in the city of London turned things around. After we included a variable that measures if the property is in London City, everything falls into place. Larger properties are more expensive and vice versa. Okay, before we wrap up, an important remark. The incorrect exclusion of a variable, like in this case, leads to biased and counterintuitive estimates that are toxic to your regression analysis. An incorrect inclusion of a variable, as we saw in our adjusted R-squared lecture, leads to inefficient estimates, which don't bias the regression, and you can immediately drop them. So, when in doubt, just include the variables and try your luck. What's the bottom line? Omitted variable bias is a pain in the neck. It is always different, always sneaky, and only experience and advanced knowledge on the subject can help. Always check for it, and if you can't think of anything, ask a colleague for assistance. Thanks for watching.